So we shall be going to discuss that one again. Okay, that why do particles of matters are means they have a space between them. Everyone, is there any students who have concern with this one? Javeri, are you there?
Yes, sir.
Please turn on the camera. So, is there anyone who is having any concern with that? Why do particles of matters have a space between them, and how can we prove this one? Or should I explain you one more time? Okay, let me explain you one more time this one. That why do particles of matters? We say that particles of matters have a space between them. So this I was just explaining the previous student. So what is this one? That we have 100 ml of water. This is the level of water. We will initially mark this one as 100 ml. Okay, we take purely 100 ml of water. Okay, and then we add some amount of sugar to it. Okay, like 2 or 3 tablespoon of sugar when we add it. So slightly when you add a 2 or 3 tablespoon of sugar, then it will increases the level of the water. Okay, it is the condition when no sugar is dissolved, means sugar is not being dissolved. Are you getting my point? So the level of the water will rises up, but when you dissolve this sugar, then again the level of the water will reaches to its original value, which was previous one. So why does the level decreases down? Why does it not increases? Why it is having the original value? Just because that the particles of sugar goes into the intermolecular space. Got it? Is that clear to everyone?
Yes,
Is
sir.
that
Yes,
clear?
sir.
Okay.
Yes.
So this we have written also. You all have written this one, noted down this one, that particles of matters have a space between them. There are so many examples you can take. Okay, that particles of matters have a space between them. Now, do you think that if you are having a sponge, okay, and you add some water to it, it will soak that water. Do you think that it is going to have a space between them? Is that a good example of a sponge? Yes, Tanisha, Chakrika, and Javaria. Is that a good examples that particles of matters have a space between them? If
Yes,
you
sir.
take, if you are taking a sponge and you add some water to it and it store that water inside it, is it good to say, Chakrika? Is it good to say?
Yes.
No, it is not so. Please turn on your camera. Everyone is requested to keep your camera turned on. No one is allowed to keep camera turned off because it's eye to eye contact is very important when you are teaching. Okay. So what I'm saying here is that it is not. Why? Because that space is not considered as an intermolecular space. That is not an intermolecular space. Okay. That is not an intermolecular space. If you are having a sponge is having air inside it. Sponge is having air inside it, not the, okay, that is not an intermolecular space. So this is a sponge, it is having tiny pores. Here there is no matter is present. No matter is present. Okay. So in that matter, the water get, okay, in that one, water is filled up. Okay. Water is filled up. So we'll simply say that this is not an idea or this is not a good explanation or it is not a good example to say whether the particles of matters have a space between them, because that is, there is no air. There is air only. In a sponge, there is air only. There is no particle of matter there. Okay, like for example, you on the bigger scale, you can say that if you are having a glass, you add some water to it. Is it good to say that it is holding that water? It means it is occupying, it is having space between it. No, we are not talking about that one. We are talking about the particle level, which are very tiny, very small. Even you cannot see it with the help of naked eyes. Means you can't see those particles. So simply we will say that the particles is that, like for example, this is water particle H2O. Let me show you this one, that this is H2O. This is H2O particles. Okay, they are arranged like this. They are having this pattern. In water, they are having this pattern. Okay, and they are having this pattern. So in that space, the particle is being occupied. The sugar particle goes. So this is water particle H2O, H2O, very shiny, very small particle. that you can't imagine. Okay, that you cannot see with the naked eyes. So in that tiny particles, they have the space. But in a sponge, where there is no sponge particle, or sponge is made up of some matter, na? There is no matter there, and there is empty space, and there that space is occupied by water, like a glass is having empty space, and we add water to it. So it is not a good explanation to say that if you are having a sponge and you add some water, it indicate that it has space between them. No, it is not so. Got it? Got my point, everyone? Got my point? So it is the best example that
Yes, sir.
water is simply uh, when we add something to water, it gets dissolved inside it. And one thing you need to note it down, that whenever something is formed, like for example, this is a colored substance. There is a colored substance. Let me explain you one thing, that like for example, you add some color to it. Like I'm saying that this is water, and you add some colored substance to it, color substance. Okay. And then you dissolve it. After dissolving, if it become colorless, means again the water become transparent. Like you add something which is white in color, okay, to water, and you dissolve in it, and again it become colorless. Then we will say that it goes into the intermolecular space of water. If it is still showing the white color, it means it is not dissolved. It is not dissolved. Are you getting my point? What I'm saying? If you dissolve something in water, if you are dissolving some colored substance in water, okay, and after dissolving some colored substance, if it is not becoming colorless again and not showing the color of water, then it means you have added something to it which is not going into the intermolecular space. It is the particle size is big enough. Not everything can be dissolved in water. Like you can say that if you are having sand particles, you try to dissolve. If you are having mud, yellow particle of mud, you want to dissolve it, you can't dissolve it. You can't dissolve. So everything in the water can't be dissolved. The particle size must have some particular range, that it should be so small. For example, the size between something is this one. Okay, how can you fix this particles in between these? If these are the particle and they have the space, only this is space empty, how can you fit this one into this one? So the sand particles have bigger size, so it do not dissolve. So everything cannot be dissolved. But if something is dissolved, then it will then in, like for example, if I'm taking the water is colorless, so if you dissolve something in water, and if again become colorless, then it indicate that it is it goes into the intermolecular space. Okay, are you getting my point? What I'm saying? Okay, because even the light that is a different concept that we're going to discuss some other day, or some other things. Okay, when we are studying some different chapters regarding to light. Okay, now moving to the next part is next property of matter is simply that particles of matters.
Good evening, sir.
Good evening, Naisha. How are you? Is I'm audible to you? Please turn on your camera. Why are you late? Okay. Next property.
I had a party at my friend's house. Sir, could you teach what you thought?
Okay, I was just explaining, beta. I was just explaining that how can we say that particle of matter have a space between them? Okay, so I just give
Okay,
an example that we have already done in the previous class also. That okay, and you have already told me that one. Okay, so now moving further. Next property of matter is of matter. Particles of matter attract each other. Attract each other. How can you say that particle of matter attract each other? How can you say? How can you say that particle of matter attract each other? Two magnets, you have two magnets, just pull it, make them closer, they attract each other. Is it the say that we can say that particle of matter attract each other? No. That is a magnetic field. There are two magnets, they are having forces, magnetic force. So they are attracting with each other. But if I'm saying that particles of matter attract each other, how can you say this one? Is there any way? Is there any way to say that? How can we say that particles of matter attract each other? So you probably all of you have done this experiment in your home. Like for example, if you have a, like just I'm saying that this is a rope. first you understand with this example. This is a rope. This is a table on which, okay, I'm just making the okay. Okay, and here we are having a rope, and the length of the rope is 5 meter. Let not 5 meter. 5 meter is like it is 3 meter. Okay, 3 meter. If I keep one end of the rope 1 meter, one meter end, this is 1 meter part, and the 2 meter part is just lying down, lying down. Okay, will it falls? Will the rope will fall down or not? You are having only 1 meter end on the table, and the 2 meter is lying, latak rahi hai, okay, it is lying down. So you will see that the rope will fall. Okay, rope will fall now. Why? Because the weight of this portion, it is 2 meter, it is greater weight. Okay, so it will attract this portion, the lighter portion, and will, due to gravity, it will falls down. But do I say that it is a good example to say that particles of matter attract each other? No, because rope is just a one piece. It is one end. Okay, so it is not saying that we can't say that it is okay. Rope is just a one piece. Okay, I'm saying that they are the two particles. One particle is this one particle is this one, and they are attracting each other. How can we prove this one? So this can be explained by the same understanding that we are just trying to explain you. Like for example, you have a bucket. Okay, and you kept this bucket full of water, and you can do this experiment at home also. Okay, you put one end of the pipe, you take a pipe, okay, and put one end of the pipe in the bucket and take another end of the bucket like this way. Okay, now imagine that this length of pipe is 1 meter, 1 meter, and this length of pipe is 1.5 meter, and they both are full with means it is full of water. Now it is full of water. Which portion will have more weight? This portion or this portion?
The outer
What?
portion.
The outer portion will have more weight. Are you getting my point? Means the water present in this portion is having more weight as comparison to this one, because it is having only 1 meter pipe. Okay, I'm talking only the water which is present in the pipe, not in the bucket. Okay, so this will have more. Okay, now what you do, you just suck one end of the water. It is empty pipe. Now you suck it, it will come, you now unless and until the water will comes into your mouth. Okay, you take one end, you suck it. Okay, and then when you have the water inside it, inside your mouth, just put the pipe down. Instantly put the pipe down. You will feel that the whole bucket will get empty, and the water will continuously keep coming. Why the water is coming? Because the particles of water, one particle of water attract the another particles. One particle of water attract the another particle. The previous one will attract. It is like a chain. They are not bonded. You can see that water is not. You can easily have your hand when there is a means water is coming. You can easily pass your hand. Means they are not like like the rope. But why it is continuously carrying water down? Why the water is continuously coming? Because at this portion, the weight of this water is more as and in this one. The same like the rope, the portion of this one is having more weight and it is having lesser weight, so it will attract the lesser weight and will make it bounce. And reason behind it is that why it is attracting, why they are, because the particles of matter attract each other. Water particles are attracting one another. So here one particle, another particle, other particle, this particle, this particle, this particle. 1 2 3 4 5 6 7 8 9 10. Okay, 8 9 10. And now this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these are having more weight. So as they are attracting, so these will keep on attracting this one. It will keep on attracting this one, and this will move upward and this will come downward. So this is the way that how does the particle of matter attract. Moreover, like you see the shape of solids. So some, like for example, you have a phone, mobile phone, your table, your laptop, they are having fixed shape. Why do solids have fixed shape? Because the particles of matter, they are having particles which are tightly packed. Okay, are you getting a point? Which are tightly packed. And because of that, solids have fixed shape. They can be easily drawn into thin wire, particles of matter. Why, if you are having why means how you can convert a sheet into a piece of iron into thin sheet, and why, how can you draw that one into thin wire? How it is possible? Why they are not breaking? The reason behind it is very simple. Just because particles of matter attract each other, they are not breaking. If you are having, even if you are having, it is becoming thinner and thinner. Why they are not breaking? Just because the particles of matter attract each other. Okay, but I'm not saying that every particle of matter will have the same force of attraction. The different kinds of matters have different force of attraction. Like gases have lighter force of attraction as comparison to that of solids. Particles of solids attract, the force of attraction in solids is more as comparison to that of gases and liquids. But I have in liquids, in solids, particularly if I'm talking that all solids will have same force of attraction. No. If you have a chalk, you can easily break it. But if you have an iron rod, you can't break it. The particles of iron have more force of attraction as comparison to the particles of chalk. Are you getting my point? So in solid also, different matters can have different force of attraction, but they attract. Point is they attract. Okay? Are you getting my point? They attract. Sometimes when you have your books that is already having some plastic cover, and you kept in the bag one book over the another, you will find that they got a stick. They got a stick. Okay? So why they got why they got stuck? Just because the particles of matter attract each other. Okay, are you getting my point? So this is an example that how we can explain that particles of matter attract each other just because there are different things. Like you have a tissue paper, you put a drop over it, and one thing is that this is not same that the particle of matter will attract the same particle of matter. No, different particle of matter can attract different. Like for example, water particle can attract water particle also, but it can also attract the other particle also, other matter particle also. Like for example, if you are able to wet something, you are able to wet the cloth. How it is possible that clothes are wet? Because the particle of clothes attract the water particle. That's why. Otherwise, you will not be able to. Have you seen something hydrophobic paints? Even if you put an hydrophobic shirts, hydrophobic shoes, that even if we put the water or mud over it, it will not let it to wet. It will not let it to wet. You have seen the cuticle layer of leaves. Even on the rainy season, they have, like on the lotus, like the plants which are hydro plants. Okay, that's uh, that grows in water or on water surface, because they are continuously in contact with the water, so that they do not get damaged with the continuous contact with the water. So they have a layer, they have a thick layer of cuticle, that is a greasy layer, that is hydrophobic in nature. When water put up over it, it does not let it to wet. So some matter attract water particles, some matter do not attract water particles. Are you getting my point? So the concept of wettability, where does the concept of wettability come? That something is able to wet something, because the particles, different particles should attract each other. Like if you put a drop of water on a tissue paper, it is spread, it got spread and form a big, we can say that, form a big circle, or okay, a point or over there. So why it is so? Because the tissue paper particles are attracting the water particle. That's why. So when along with, why this, the upliftment of water, if I'm talking that, how does the water from the ground just to top of the plant is 100 meters, there is no pump, there is no water pump. Have you seen the concept of diya? The one end of the diya is put in the oil, another end is above the oil. How it is going against the gravity? just because the oil particle is attracted by the diya particles. And also oil particle is attracting the its oil particle. So when, like, this is the diya, this is the cotton particle. I'm just using this one with blue color, cotton particle with blue colors. This is the cotton particles, and this is the oil particle with red color. So this red color particle will attract this particle which is in front of it. So it will come here. Now this particle will attract this particle, and it will comes here. And along with this red particle will attract the previous red particle of oil. Oh, we can say that oil particle, because red is oil. I'm just indicating here. Okay. So not only the oil particle is attracting the oil particle, it is also being attracted by the cotton particles, from which cotton is made up of. And this is a concept that how does the water reaches in the top part of the plant, 100 meter top plants. Okay, the ground, they just suck the water. The one end of the water, we just only put the water in the soil, and then it reaches to the top of the plant in the leaves. Why it is so? Just because of this theory, this attraction theory. Okay, if the water particle do not attract another water particles, and if the water particle does not attract the wooden particles, then it will not help it to reach to the top of the plant. Okay, are you getting my point? So there are several examples that you will in your daily life, you can assume that why does it happen. So this is because of the attraction between the particles of matter. Okay, are you getting my point? Is that clear, everyone? Okay. So, and one more property, let's you write it first, then we shall be going to discuss that how can the particles of matter attract each other. Particles of matter attract each other. Everyone understood this one? Tanisha, you understood that why do particles of matter attract each other? And can you means is there any doubt regarding to this topic? Will you be able to
No, sir, it's clear.
clear? You, Tanisha, sorry, Naisha, you understood? Is it clear to you, Naisha?
Sir,
And you, Javaria, is it clear to you?
Yes, sir.
And you, Chakrika, is that
Yes.
clear?
Yes.
Okay. Upliftment of water in the trees. Okay. Uh, that I was explaining was that capillary reaction. Okay, capillary reaction means that when you suck one end of the water, okay, uh, in the bucket, another end is put in the bucket, and you put the pipe down, then the water will keep moving. One condition is that the water that is in the pipe that is outside the bucket, it should be, the other end should be lower than bucket. Okay, lower than the bucket, then it will keep on coming. You can do this experiment in your home.
So what is after R
What is after
or
or this is wire,
okay?
thin sheet or wire.
Yes, sir.
When you're done, please let me know.
Sir, can you please scroll the screen down?
Sir, done.
Done. Okay, so I'm going to explain you one thing here is that which should be you have noted this one up to here, everyone.
Yes, sir.
When you're
Yes,
done,
sir.
please take a sheet of paper. Take a sheet of paper in your home that you will be going to have. Okay, that is rough sheet or a paper. Means just have a sheet of paper. Okay, all of you have a sheet of paper, please. Means it should be. Do not tore it from your copy, or if it is means tore it from that portion from which means that is a rough copy. That means okay. Do not tore it. It should be a rough page or any page. Just have a page in your hand. All of you. All of you having?
Yes, sir.
Yes, sir.
Okay. Now make that sheet. Do not means I need to say that please. I'm saying that if your mother don't like क्या कहते हैं उसको गंदगी, okay, so please keep your page because I'm just asking you to tore that page. Okay, so yes, whatever the sheet you are having, just make it half, exactly half. Okay, try to do it. Okay, done. Javeria done.
Yes, sir.
Now it is half. You tore it half. Now take
Yeah.
that half. Now take that half part. We have done one time now. Till yet we have done one time. Okay. Now tore that half part again. Means tore that sheet. Means fold that sheet again and then tore it half part. This one. Now we have done two times. Now make it half and then do it again. Done 3 times? 3 times? Okay. Now do it again. Make it half and do it again. We have done 3 times till yet, na? Now it is the 4th time. 4 times. Now 5 times. We have to do it up to 8 times. 7 times up to. We have done 4 times. Up to 4 times we have done. This portion. Okay, now the 5 times. Do it one more time. You have done 5 times. Then
Yes.
6th time. And do the 6th time. It is very, very tiny, na? This is the 6th time, Tanisha.
No, sir, this one is 7. The one
7th
I'm
time, na?
about to play.
And your Tanisha, Naisha, could you imagine? Could you imagine that if you do this 10 times, 10 times, this one, na? Now imagine that this is the how much you have done? How many times you have done? 6 times you have done. 7 times. 7 times everyone done.
Yes, sir.
What is the what is the size of piece? Can you show me your piece?
So I've done 8.
You have done up to 8. Okay, it's very similar, na? Okay. Now if I ask you that this is the one time that you have done. मान लेता हूं कि ये आपने 10 दफा करना है. अगर आप 10 दफा करते तो you will have this much. इतना साइज आता है आपके पास. If you do it with the 10, let me show you the size of the sheet. Okay. Just imagine that you have this one. If you have this size of sheet, let's suppose you have this size of sheet, then if you done it 10 times, then you will do this. You will have this one. You will have this one. This is like, let's suppose this is 1/10 of this sheet. 1/10. Okay. Half, then again half, then again half, then again half. This is 5. When you have done this one, this is 1. Okay. got my point? अब एक बात समझो. अगर मैं तुमसे बोलूं कि ये जो है ना, ये शीट, ये तुमने अभी एक बार किया है. ये इतना छोटा जो है, ये 1 टाइम है. इसको मैं 1 टाइम मानूंगा. अभी इसी शीट को फिर से जो आपकी ये 1/10 शीट है, इसको फिर से आप 10 बार डिवाइड करो. ऐसे ही तोड़ो इसको. फिर वो जो छोटा सा पीस आएगा, उसको फिर से 10 टाइम्स करो. इसको 10 टाइम्स करो. इसको पहले फोल्ड करो, फिर ऐसे करके जैसे आपने इसको किया ना. यू हैव टेकन दिस बिग शीट एज वन शीट. You start doing, you got this one, this piece. Then just Chakrika, look at this please. Then you break this one. Okay, this is your, now instead of this paper you have to take this sheet and do it the same. Do it the same that you have done. Now you will get, when you do this one, you will get 1/10 of this one is this one. Now again you have to do this one with this one. अब की बार ये शीट नहीं लेनी, आपको ये लेनी है. Now this is 1/10 of this one will be like this one. ना इसके बाद भी आपको, इसके बाद भी अभी नहीं करना, उसके बाद फिर से 1/10 करो. तो फिर तो आपसे हो ही नहीं पाएगा. आपसे तो यही नहीं हो पाएगा. समझ रहे हो क्या कहना चाह रहा हूं मैं? आप नहीं कर पाओगे because it will go to the.
Doing this 10 times and then I'll show the papers.
You have done this one. This is 10 times. Okay, this is very, very tiny. Yeah, you have done this one 10 times. Huh? This is very, very small. Very, very small. Now, if I ask you again, fold it, then do it half, then whatever the piece you get, again you repeat that process with this sheet, not this that paper you have taken. Again you have to do this one. Then what you will do? This is very, 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 very small. Okay, then again, whatever the paper you get at the last, again you have to do this one, and you have to do this one continuously. It is very, very it will become very, very small. Okay, so what we are saying here is that when we have an experiment of dilution, you can understood this one, that for example, if we have 100 ml water, 100 ml water, okay, fresh water, 90, okay, or we can take the 90 ml of water, 90 ml of water, and add 10 ml of potassium permanganate to it. Or you can have the 100 ml and add some crystal of KMnO4 to it, potassium permanganate, पोटेशियम पर मैग्नेट टू इट आपने डाला इसके अंदर, ये पूरा पर्पल हो जाएगा। उसके बाद आपने इसमें से 10 ml लिया, तो 10 ml क्या है इसका, 1/10 पार्ट ही तो है। 10 ml क्या है, 1/10 पार्ट। इट इज जस्ट लाइक यू हैव अ that you have a sheet of paper, okay, and you have taken 1/10 part of it, that was that small tiny part that the Naisha has done, that small part from a sheet। अब आपने उसको नई बीकर में डाला, इसमें फिर से 90, दिस इज 90 ml ऑफ वाटर इज प्रेजेंट हियर। आपने इसमें वो 10 ml जो थी शीट के बराबर का छोटा सा, वो इसमें डाला। फिर आपने इस सॉल्यूशन में से फिर से 90 ml लिया, सॉरी 10 ml लिया। 10 ml का मतलब इस शीट को आपको पहले हाफ करो, समझ आया, शीट से समझाने की कोशिश कर रहा हूं मैं। जो आपने उस बड़ी वाली शीट के साथ किया था ना, वो इस 1/10 पार्ट जो आपका आया था, उस शीट को 10 बार डिवाइड करने पर, उसके साथ अब ये 10 करना है तुम्हें 10 बार। वो बहुत बहुत कम होगा ना, कुड यू इमेजिन वो कितना छोटा साइज आएगा। इसको पहले फोल्ड करो हाफ में, फिर उसका जो पोर्शन आएगा उसको हाफ में, फिर उसका जो पोर्शन आएगा उसको हाफ में, फिर उसका जो पोर्शन आएगा उसको हाफ में। यू कीप ऑन डूइंग, यू विल फाइंड दैट दिस पीस विल कम, दिस विल कम, ओनली अ स्मॉल पार्ट। जस्ट इमेजिन ये एक बड़ी वाली शीट का सिर्फ इतना सा पोर्शन है। ऐसे मैं समझाने की कोशिश कर रहा हूं तुम्हें, ओके। उसके बाद फिर से आप इसमें से इसमें डालेंगे 10 ml सॉल्यूशन, एंड दिस इज 100 ml, ओके। ना उसके बाद आपने, ओके, उसके बाद फिर से आपने फ्रेश वाटर 100 ml 90 ml पानी लिया, एंड देन अगेन यू आर एडिंग इन दिस 90 ml of water, you again adding 10 ml from this portion, but still you will get some purple color. What does it indicate? What does it indicate? That the particle of matter is very 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 tiny, very very small. Purple color is just because of the potassium permanganate, KMnO4. So when we keep on dividing, keep on dividing, keep on dividing, keep on dividing, even if we are dividing it, it will keep on dividing. What does it mean? If something is having bigger particle, it will not keep on dividing. But if it keep on dividing, keep on dividing, keep on dividing, it means that it is very very tiny. Are you getting my point? समझ आया? अभी आपने वो शीट ली थी, उस शीट में से आपको इतना आया, फिर उसका 1/10 पार्ट किया, तो आपने एक बार ये आ गया आधा, फिर इसका आधा ये हो गया, फिर उसका 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 आधा ये हो गया। अब ये इतना सा पोर्शन आया आपके साथ, इसको भी वही रिपीट करो। मैं स्क्रीन पे लिख भी नहीं सकता, इट इज नॉट पॉसिबल, बट यहाँ पर हो रहा है ऐसा। व्हेन यू आर डायल्यूटिंग दिस सॉल्यूशन, इसका मतलब ये है कि ये इससे 1 करोड़, अगर इफ यू हैव डन 7 टाइम दिस प्रोसेस, इट मींस इट इज 1 करोड़ टाइम डायल्यूटेड दिस वन। इसमें अगर एक पार्टिकल है तो इसमें 1 करोड़ पार्टिकल होंगे। समझ में आया? if we have diluted this way, by this way 7 times, 7 times, why I'm saying 7 times, because 7, there are 7 zeros in 1 crore, okay। so अगर इसमें एक पार्टिकल होगा या इसमें 10 पार्टिकल होंगे, तो इसमें 1 करोड़ पार्टिकल्स होंगे, 1 करोड़, if you have done 6 times, do you imagine? तो 6 टाइम करने के बाद भी आपको उसमें मिल रहा है पिंक कलर, वायलेट कलर मिला, it indicate that it is the particle of matters are very very small. Let me explain you with the help of video. How does particles of matters, we say that particles of matters are very very small? So let me explain you with the help of video. Okay. So you can watch it here that these are the 5 beakers and he is having only this much particles. Okay, and you keep on dividing. This is the dark color of potassium permanganate will be observed. And now when he took this one, okay, now imagine, just imagine for a number, just imagine that it is having this part, this solution is having 1 crore particles of KMnO4. 1 crore is a big number. Don't think that 1 crore is easy. So it is having 1 crore particle of potassium permanganate. So when he took a syringe of 10 ml, then how much particle will come? How much? It is 100 ml na total. It is 100 ml total. Okay. If you take 90 ml water is in here, but and only taken the 10 ml, then how much water is there? Okay. Are you trying to get my point? अगर आपने इसमें 100 ml, उसमें सिर्फ आपने 10% लिया उसका, तो 10% ऑफ 1 करोड़ इज 1 लाख पार्टिकल. सो 1 लाख पार्टिकल अभी इसके अंदर आ जाएंगे. सॉरी, 10 lakhs 10%. सो 10 लाख पार्टिकल्स आर देयर. 10 lakhs, 1 करोड़ से 10 lakhs इसमें आ गए. अभी भी ये बहुत डार्क है. अब 10 lakhs से इसमें कितने आ गए? इसमें फिर से 10 ml लिया, तो अब इसमें आ गए हैं कितने? अभी भी ये पर्पल कलर का है. ठीक है. और इसमें अब आ गए हैं 1 लाख. 1 करोड़ 10 lakhs 1 लाख. 1 लाख फिर से इसने लिया, उसमें से फिर से 10% लिया, तो अब इसमें कितने आए हैं? देर इज 1 लाख का 1000. ठीक है. सॉरी, 10,000. 10,000 से फिर 1,000. स्टिल इट इज हैविंग सम पर्पल कलर. तो अगर मैं बोल रहा हूं कि 1 करोड़ में से आपने 1,000 के उस पर पैमाने पर आप आ गए 1,000 हियर. सो इट मीन्स दैट यू हैव डाइल्यूटेड इट मल्टीपल टाइम्स. ओके. तो अभी हम लोग को ऐसे पानी डालते जाएंगे तो पता नहीं चलेगा ना कितने गुना आपने डाइल्यूट कर दिया. तो ये आपने बहुत ज्यादा डाइल्यूट कर दिया सॉल्यूशन को. आपको लग नहीं रहा है लेकिन ये बहुत ज्यादा डाइल्यूटेड है. ओके. तो यू कैन इमेजिन विद दी पेज वाला एग्जाम्पल जैसे मैंने आपको दिया था. समझ आया? तो अभी भी ये दिख रहा है हल्का सा पर्पल कलर. तो ये क्यों दिख रहा है? जस्ट बिकॉज द पार्टिकल्स ऑफ मैटर्स आर वेरी वेरी टाइनी. दे आर वेरी वेरी स्मॉल इन साइज. अदरवाइज बड़ा पार्टिकल होता तो इतना इतना तो डाइल्यूट ही नहीं हो पाता. और यहीं पर हमें दिख जाता, उसके बाद हमें जाता ही नहीं. Are you getting my point? Are you trying? If something is keep on dividing, so what does it means? It means it is very very small. समझ आया? समझ आया?
Yes, sir.
Okay. So
Yes,
let's you write this one, and in the proper way, uh, that how can we say that particles of matters. So the question came in examination: illustrate an activity to show that the particles of matters are very very small. So Chakrika has written this one yesterday. If you have not done, then you can write it. Otherwise, you can take. Okay. You need not to write it again. Okay. So please, other students, please start writing this one. That particles of matters are very very small. The question came that illustrate an activity to show that particles of matters are very very small. Take
sir,
two, three.
for the previous one, I didn't write the last line. Can you show it?
For this one.
Yes, sir.
No. You have written this one. वो
Uh,
आगे है. या वो
the
आगे है.
second one.
वो मैं दिखा दूंगा. उसके लिए छोड़ दो अभी स्पेस. जस्ट
Oh,
पुट
okay.
गिव वन स्पेस. ओके.
Sir, can you please hold?
Take 2 or 3 crystal of potassium permanganate and dissolve them in 100 ml of water. Take out the approximately 10 ml of water of this solution and put it into 90 ml clear water. Okay. Take out 10 ml of this solution, put it into another 90 ml of clear water. You're done?
Yes, sir.
Yes, sir.
Observation and results.
Yes, sir.
Sir, done.
Done. Okay. So, yes, Naisha, you done? Still writing.
Just the result I need to write.
Okay, note it down.
Sir, done.
Okay. We'll practice different types of questions. You will given an assignment that why do a diver is able to cut when he's swimming. Okay, he is able to cut the water. So which property of matter is explained here that he is able to cut the water? That particles of matters attract each other. Space between them तो नहीं कहेंगे कि स्पेस तो क्या तुम उसके स्पेस में थोड़ी ना जा रहे हो. अगर तुम उसके स्पेस में जाने के बाद दिखने बंद हो जाओ तब तो तुम उसके स्पेस में चले गए ना. एनीथिंग विच गोज हम बोलेंगे कि आपको दिखे ना वो चीज. ओके, अब ये मत कहना कि सबमरीन तो सर अंदर चली जाती है पानी के तो वो तो दिखती ही नहीं है तो फिर क्या वो इसके स्पेस में नहीं. स्पेस का मतलब होगा पार्टिकल्स, बहुत छोटी छोटी स्पेस, मतलब बहुत पार्ट वाटर के पार्टिकल्स के बीच में स्पेस. ओके, दैट यू कांट सी. ओके, दिखे ना, इवन दो कलर भी ना दिखे. ओके, तो हम बोलेंगे कि तो डाइवर इज एबल टू कट बिकॉज पार्टिकल्स ऑफ मैटर अट्रैक्ट ईच अदर, बट आपने उसको हाथ से ऐसे किया तो वो हट गया वहां से, फिर दोबारा से आप हटेंगे तो फिर वो पानी दोबारा आ जाएगा. तो वो क्यों आ रहा है जब एक बार अलग हो गया? क्योंकि वो अट्रैक्ट करते हैं एक दूसरे को. ओके, और यही था. और इसके अलावा देयर सम क्वेश्चन यू विल बी मींस सम क्वेश्चन विल बी गिवन टू यू इन द असाइनमेंट दैट यू हैव टू डू. ओके, दैट व्हाई व्हिच प्रॉपर्टी इज रिसेंबल्ड बाय दिस टाइप ऑफ एक्टिविटी, कि कौन सी प्रॉपर्टी मैटर की रिसेंबल हो रही है. सो आई होप you enjoy the class. Yes, you, Naisha, you can write what you were saying, that you forgot to write this one, the last line. So you can write it.
Sir, I'll just take a picture.
Okay, you can
And
take a picture. You can take it. So, Javaria, you understood this one? And you, Naisha, sorry, Tanisha,
Yes, sir.
you also? Okay. So, आज के लिए
Yes,
इतना ही.
sir.
We'll meet you in the next class. Thanks for coming. Okay, you can leave.
Thank you, sir.
Thank you, sir.
Bye, sir.
Sir,